Good evening everyone. Myself Phani. I am working as assistant professor in St. Peter's Engineering College, the Department of Civil Engineering. And today my topic is design of beam. So first of all, what is design? So design means to calculate the number of bars, longitudinal bars and stirrups, area of cross section, and effective cover. So before going to discuss the design of beam, to analyze the structure, one is the element of a. So first of all, beam is it is a horizontal member subjected to number of loads, nothing but point load or concentrated load, uniformly distributed load, uniformly varying load, or couple or moment. So I will draw types of beam. So first one is simply supported beam. Second one is cantilever beam. And third one is continuous beam. So simply supported beam means a beam rests on two supports, and cantilever beam is one end is fixed, other end is free. This is the free body diagram. This is free end. This is fixed support. And continuous beam. More than two supports is known as continuous beam. So coming to supports. Supports are, there are three supports are there. Fixed support, second one is hinged, and third one is roller support. These are the figures. So to calculate, first of all, if a structure is stable or unstable, to based on degree of static indeterminacy, to calculate the degree of static indeterminacy. So formula for beams is 3m plus r minus 3j. So m is member, r is unknown reactions, and j means joints. Let us take an example, fixed beam or fixed support. Here, to calculate the ds value, this is a cantilever beam. So one end is fixed support, other end is free end. So ds is 3a plus r minus 3j. So how many members are there here? This is one member, and joints are 2. So I am writing the value, m is 1, j value is 2 joints. Joints means connection. Connection of two members is known as a joint. So here r value is unknown reactions. To calculate the unknown reactions based on equilibrium equations, there are three equilibrium equations are there. One, horizontal force, second one is vertical force, and last one is moment, applying moment. So for fixed support, applying three forces: horizontal, vertical, and moment. So if you apply fixed support, if you apply a horizontal force, there is no moment here. So here R value is 0. Next, vertical force. You are applying vertical force at a fixed end. Here also there is no moment. So here also R value is 0. Applying moment. Moment is nothing but the product of force and perpendicular distance. So applying that at fixed support, here also there is no moment here. So here also R value is 0. So by taking these values, R value is 3 reactions. Therefore ds equal to 3m plus R minus 3j. Member is 1, unknown reactions plus joints. Joints are 2. Therefore the ds value is 3m plus R minus 3j. 3 minus here 6 minus 3. We got the value, ds value is minus 3. So after that, next we have to calculate the analysis the beam to calculate shear force and bending moment. So this is the major part in civil engineering. It comes under strength of materials. So let us take an example: a simply supported beam subjected to concentrated load at center point. Here is W. Here span is A, B point and C point. The overall length is L, nothing but clear span. So by calculating shear force is nothing but it is the algebraic sum of all forces, entire section. So calculation of shear, before going to that, to calculate the support reactions. How to calculate these support reactions, sir? Sum of upward forces equal to sum of downward forces. Sum of downward forces. So here forces are, upward forces are RA plus RB, that equal to downward forces. The figure is, this is support point at A, this is support point at B. A point, B point and C point. Sum of upward forces equal to sum of downward forces. So RA plus RC equal to W. So next point is moment about A equal to 0. So why we need to take either moment about A equal to 0 or moment about B equal to 0. Moment is nothing but the product of force and perpendicular distance is known as bending moment. So taken from points RC to from A point, here one upward force is there, the force into perpendicular distance, here the span length is x. So RC into multiply with L, that equal to Next, another force is W multiply with, here the span length is L by 2. Here the load acts at center point into L by 2. So therefore RC is equal to W L by 2 into L. L gets cancelled. Therefore the value is W by 2. So substitute in first equation the RC value, RA plus RC value is W by 2, that equal to W. So therefore the RA equal to W minus W by 2, that equal to 2 is LCM, 2W minus W, that equal to W. Therefore RA equal to W by 2. Simply we can say that if a load acts at center point, the support reactions share half of the load. Why? Because it acts at center point. So now shear force. Shear force. Shear force is nothing but it is a sum of all forces. This is the A point, B point and C point. This is the load W. So here length is same L. Okay. Shear force. The span length is, let us take an example, span AB, A point, A to B. Consider a section. Consider a section. Consider a section from X at a distance from point A. From point A. So shear force at X. Here how many forces are there? Totally only one force is there, nothing but RA. We got the value RA is W by 2. Simply we can say that if a load acts at center point, load shares the equal. Half of RA and half point is RC. Therefore the shear force is only one force is there, nothing but RA. Then you should know about the sign conventions also. Sign conventions for shear force, bending moment. Here left of section LOS and right of section ROS. Here upward force is positive, downward force is positive. Here downward force and upward force is negative. And bending moment, clockwise, anti-clockwise, positive, anti-clockwise and clockwise, negative. This is downward, anti-clockwise, this is upward force, this is downward force. So here consider a section. Here only one force is there, that is RA. Sign conventions, here this is the left side, left of section. Force is upward force, take it as positive sign. Only one force is there, that equal to W by 2 kilonewtons. And shear force at X equal to 0. Let us take an example. For example, for span length is from 0 to or 5 meters or 10 meters. At X equal to 0. Shear force is same, that is RA, that equal to W by 2 kilonewtons. Shear force at X equal to half of the length, L by 2. RA equal to W by 2 kilonewtons. Coming to bending moment. consider a section. Again, consider a section. Bending moment. Bending moment is nothing but force into perpendicular distance. Here the force is, consider a section, here only one force is there, followed by one horizontal upward force RA into the distance is x. Force is W by 2 and distance is x. Here the bending moment at x equal to 0, that equal to W by 2 into distance is 0. Bending moment at x equal to L by 2. At x equal to L by 2, the force is W by 2 and the distance is L by 2. Therefore the value is WL over 4. Here coming to sign conventions. What is sign convention? Here their anti-clockwise left of section is positive, right of section is positive. Anti-clockwise is left of section is positive. So here this is positive sign, here also positive sign. Therefore the value is plus W over 4. So this is the bending moment value. So this is the analysis part. Here we got the value, shear force is W by 2, bending moment is WL over 4. For simply supported beam subjected to concentrated load. B point. Okay, here for example, if a simply supported beam subjected to UDL, the shear force is WL by 2 and the bending moment is WL square over 8. Based on the sign conventions, this is plus, this is also plus. Okay, now design of beam, design of simply supported beam subjected to UDL. So and also the data is M20 grade concrete and Fe415 steel. Here you also know that live load is 15 kilonewton per Newton. Here beams are nothing but frames. Here design of simply supported beam subjected to UDL and the grade is M20 grade Fe415 steel and the live load is 15 kilonewton per meter. So sir, their design steps based on IS code book IS 456 2000 code book. We followed the IS codes IS 456 2000. So in that page number 87, here moment values are there. Moment of resistance, limiting moment, we use the formulas from that part. Now the first step is to calculate the depth of beam. Calculate the depth of beam. As per Indian standards, we take the formula L over 12 to L over 15. Here the span length is assumed as 6 meters beam. Take it as 6 meters. 6 meters is nothing but 1 meter is equal to 1000 mm. So 6000. Here the length is 6 meters. 6000 over 12 to 6015. So I am using calci. So got the value 6000 divided by 12. The value is 500 6015. This is 400. We can assume that formula minimum 400 to 500. So I am taking the value 450 mm. The depth of the beam is 450 mm. Assume. Here I am drawing the cross section of a beam. The beam cross section. This is breadth and this is the depth. Overall depth. Capital D we taken as. Small d is for effective depth. Actually this is the actual figure calculation. We are calculating these bars in design of beam, calculating the breadth, depth and number of bars, stirrups and cover also, effective covers, clear cover. So small d is taken from top to center of the bar and remaining is effective cover. Here we got the value small d is equal to 450 mm and cover as per Indian standards for beam we are taking the cover is 20 to 30 mm or 25. We are taking the 20 mm minimum. So therefore the overall depth is 450 plus 20, that equal to 470 mm. So this is the depth of beam calculation value for 6 meters beam. And next one is calculation of breadth. This is based on depth value. So d by 2 to d by 3. So we got the value depth is 4. So this is the overall depth. This is small d. Here you have to substitute it 450 value. 450 divided by 2 to 453. So the 450 divided by 2 is 225 to 450 divided by 3, 150. So the value taken from minimum is 150 to maximum value up to 225. So I am considering the 200 mm. Our assumed value 200 mm. This is the breadth. So we got the value B is 200. Overall depth is 470 mm. So first step we are calculated the cross section of a beam. Next step is calculation of loads. This is the major part in civil engineering. So coming to loads, there are so many types of loads are there. Concentrated load, uniformly distributed load and uniformly varying load. So here those are the application of the loads. Here and again calculation loads, taking the dead load, nothing but self weight of that material, dead load, live load and snow load also. Here you are not considering that snow load. In foreign countries you are taking that snow load also. So how to calculate this dead load? So dead load has IS standards. One formula is there: density of concrete multiplied by area of cross section. Area of cross section of a beam. And live load. Here in given data we got the value. Here given the live load is 15 kilonewton per meter. 15 kilonewton per meter. So therefore the dead load is, here the density value, density is nothing but mass by volume. For concrete the value is 25 kilonewton per meter cube. This is Indian standard code. The area of cross section is 200 multiplied with depth, overall depth. Here we are taking that overall depth. Overall depth is 470 mm. Here the units are in, this is in mm. Here the value is in meter. So you also know that 1 meter is equal to 1000 mm. So you should convert it into mm into meter. So this is 25 multiply with 200 divided by 1000. So 0.2 meter multiply with depth 470 mm multiplied by 1000 divided by 1000. We got the value is 0.47. So I'm using calci. 25 into 2.47. So we got the value is 2.35 kilonewton per meter. Kilonewton per meter. So calculation total load. You are calculating total load, that equal to dead load plus live load. Dead load we got the value 2.35. 2.35 and live load, the given data value is 15. So the value is 17.35 kilonewton per meter. Okay, and next step is calculation of shear force and bending moment. We already discussed that shear force and bending moment. Here simply supported beam, we are considering that this is the concentrated load and this is UDL load, uniformly distributed load. Here the value is WL by 2 and bending moment is WL square over 8. So the shear force, we are the value WL over 2, that equal to the load value is 17.35 and the span length is 6 meters and 2. The value 17.35 multiplied with 6 divided by 2. Got the value 52.05 kilonewtons. And bending moment WL square or 8. Here the W value is that is my total load. Total load is 17.35. 17.35 multiplied by, here the span length is 6 meters. 6 by 6. Why? Because it is L square, L into L. Here 17.35, 6 multiplied with 6 divided by 8. You got the value 78.07 kilonewton meter. The units are, the force is in units as kilonewton multiplied with distance is meter. So bending moment is nothing but force, the product of force and perpendicular distance. So you got the value 78.07. So after that, next step is calculation of limiting moment. So the limiting moment are nothing but mu limit. This is taken from IS code book 456/2000. The year is 2000. You are following that Indian Standard 456 code book, page number 87. Page number 87, your formula is mu limit equal to 0.36 xu max by t 1 minus 0.42 xu max by t bd square fck. bd square fck. Here FCK is nothing but characteristics compressive strength. Here the given data you are giving that M20 grade of concrete. Steel is M20 grade of concrete. For 28 days, after curing of 28 days, the cube is 150 mm, 150 mm by 150. 28 days they tested in compressive testing machine. The value we get the 25 kilonewton per meter square. So value 0.36. XUmax D also taken from IS 456 codebook. The value is 0.48 in page number 56. Got that value based on steel. FE 415 steel, FE 500 and FE 250 steel are there. FE 250 steel is mild steel. FE 415 steel is HYSD bars, nothing but high yielding strength deformation bars. And for FE 500 is TMT bars, thermo treated mechanically treated bars. 0.42 you are taking that formula. XUmax D same 0.48 and that B value. Here the B value is breadth of beam. Breadth of beam is 200 by depth. Depth we got that effective depth is 450, not overall depth. This is small d, and characteristics is here in given data. Here you are assuming that M20 grade of concrete. So nothing but FCK is 20 the value. Here the M is nothing but mixed proportion. The grade of concrete, how much cement you are taken, cement, sand and coarse aggregate. So the value is 20. MU limit, you are calculating the MU limit. So I am using calci 0.36 into 0.48, 1 minus 0.42 into 0.48, 200 into 450 with 20. We got the value 248,334.336. Here this is in Newton mm. Actually the breadth value is in mm, 200 mm, 450 mm. Here Newton per mm square. Here Newton per mm square. After calculating that, we got the value is 248,334.336. So compare that main moment with the MU limit. Here we got the value MU value is 78.07 kilonewton meter, but our MU limit value 248,334.336. This is Newton mm, this is kilonewton mm. So you should convert it into this also in kilonewton mm. So 1 kilonewton meter is that equal to 1 kilonewton is 1000 Newton, 1 meter is 1000 mm. So 10 power 3 multiply with 10 power 3, nothing but 10 power 6 Newton mm. 1 kilonewton meter is equal to 10 power 6 Newton mm. So I am converting the value into kilonewton meter. So 10 power 6, nothing but 248,334.336 converted into divided with 10 power 6. We got that value is 0.2 or 48 kilonewton meter. Basically mu less than mu limit, mu less than mu limit is nothing but singly reinforced beam. Singly reinforced beam. Here we got the value 0.248 kilonewton meter and mu is less than mu limit. We are taking this mu less than mu limit. And next, main moment formula, mu is equal to 0.87 Fy ASTD 1 minus Fy AST by BD FCK, and this is the main moment formula. So 0.87, we are taking the same 0.87 and Fy is 415. We are calculating the area of steel, AST. Here the depth of beam is 450. 1 minus Fy, carats, this is steel, area 415 AST divides with breadth of beam is 200 and depth of beam is 450 and characteristic compressive strength is 20. So the limit, we are taking that mu less than mu limit, we are taking that value is 78.07. mu place replace with 0.78.07 with 10 power 6 Newton mm. Why? Because these are values are in mm only. So after calculating that 78.07 with 0.87, 415 with 450, we got the value is here 162472.5 AST, area of steel. 1 minus, here the total value 415 divided by 200 multiply with 450 and again multiply with 20, you got the value 2.30. Here I am writing the value again, 78.07 into 10 power 6, that equal to 162,472.5 AST. Here 1 minus the value, you got that 2.30 into 10 power minus 4. Here also AST is there. This is in the format of ax square plus bx plus c. This is c and this is x. 162472.5 multiply with 1, again it gets AST minus multiply with this value with again this multiply 162,472.5. Here 37.45 AST, with AST got AST square 78.07 multiply with 10 power 6. This is in the format as ax square plus bx plus c. To calculate x value, calculate the x value, nothing but area of steel. Based on area of steel, we get the how many number of bars and stirrups. So in Calc, go to that equation that ax square plus bx plus c, the a value is this is a value ax square, this is b value, and this is c value. Ax square plus bx plus c. Here the a value is minus value minus 37.45, apply that, and b value is 162472.5 AST, and c value is 78.07 multiplied with 10 power 6. I am entering the value. A value minus 37.45, and the b value is 162472.5, and c value is go to the direction 78.07 with 10 power 6. So we got the value is AST. After calculating, AST value got not nearly 500.57 mm square. You got the value is 500.57 mm square. Nearly we are taking that 500 mm square. We got the value A of steel. So, and next step is calculation of longitudinal bars. Calculation of longitudinal bars. How to calculate longitudinal bars is nothing but AST by A5. Here we got the value is 500 multiply with A5. Bars are in circular section. So pi by 4 area of circle formula is pi by 4 d square. We are assuming the bar diameters. Inside the bar diameters are available in 8, 10, 12, 20, 25 and 28. So minimum the bar dimensions we are using in beams from 12 to 20 and 16 also is there. For columns where the minimum bar diameter is 12, we are taking that. Here the beam, the value we are taking that assumed value, that is pi by 4, taking that 12, pi by 4 d square. So the value pi by 4 multiply with 12, we got the value is 4.42 bars. Nearly are taking that 5 bars. We are assuming that 5 bars. And next step is area of steel minimum. For every area of steel has a minimum and maximum is there. For maximum area of steel we are providing area of steel in beam is 4%. 4% of gross area. Here the area of steel, how many minimum steel based on IS code book, AST minimum 0.85 BD. So 0.85, here Fi is 415 multiply with base breadth nothing but 200 and depth is 450. The minimum steel, calculating the minimum steel 0.85 with 415, 200 multiply with 450. We got that value. The minimum steel is 390 mm square. The minimum steel we are providing that AST minimum and AST maximum, nothing but 4% of gross area. Gross area means here the section is rectangular section. So length into width. 4% is 4 by 100. Width, breadth into multiply with depth, overall depth. We are assuming that overall depth 4 by 100 multiply with 200 and overall depth is 470. Here 0 gets cancelled. The value is 4 with 470 is up to 3760 mm square. So minimum steel is the minimum 300, 391, 391 to 391 to up to maximum value is 3760. Our assumed value, we are taking that AST by A5. AST value we are taking assumed as 900 or 900 all divided by pi by 4 into 16 square. And taking that so I am multiplying 900 divided by pi by 4 multiply with 16. Here we got that 4.47, nearly 4 bars we are taking that. So in cross section of a beam we are taking that number of bars is 4 bars. And again you calculating that stirrups. In stirrups, coming to stirrups, mainly this is to restrict this shear force or to prevent the shear force, because a load act at center point, the beam will separate into two parts in point load or nothing but concentrated load. So here stirrups are the minimum value is 6, 8 and maximum value is 12. So we are considering that 8 mm as per Indian Standard Code. The beam 4 bars, its stirrup dia is, and this is 16, we are taking that, and the stirrup is 8 mm. The overall dimension is, this is breadth, this is 200 and overall depth is 470 mm. So I am concluding that from base point to so first of all, this is design of beam. Design means to calculate the number of bars, how many number of bars you are providing in beam, longitudinal bars, stirrups and area of cross section and also effective covers. So first of all, you know the beam. Beam is nothing but it is a horizontal member subjected to various loads, point load or concentrated load, uniformly distributed load or uniformly varying load. Here the types of beams: simply supported beam, cantilever beam, continuous beam. A beam rests on two supports is known as simply supported beam. Cantilever beam is one end is fixed, other end is free. Continuous beam is more than two supports is known as continuous beam. And these are the supports. There are three supports are there: fixed support, hinged support and roller support. to calculate the whether it is stable or unstable based on the degree of static indeterminacy, you got the value. So the formula is 3m plus r minus 3j. M is member, R is unknown reactions, and J is joints. So let us take a simple example for that fixed support or cantilever beam. So on three equilibrium equations, applying that on horizontal force, vertical, and applying moment. So the values, and next that shear force and bending moment. Shear force and bending moment, I am considering that first of all you should calculate the support reactions. How much load acting on the load when shared to that supports. Here the supports are A and C, are two supports are there. Load acted center point. The points are A, B, C. So calculation support reaction, the procedure is the sum of upward forces is equal to sum of downward forces. The sum of upward forces are RA and RB are upward, moving upward direction. W is moving downward direction. So sum of upward forces are RA plus RC is equal to W. The moment about A is equal to 0. The second step, this is first step, this is second step. Moment about A equal to 0, or considering that, or moment about B is equal to 0. Here the moment is nothing but the product of force and perpendicular distance. Here the consider a support reactions RC into L, that is equal to W into L by 2. We got the value RC is equal to W by 2, and substitute in that first equation, we got the value RA equal to W by 2. Simply we can say that a simply supported beam, a load acts at center point, the load will share equally shared, half part for support A and half part at support C. Why? Because it is acted at center point. Shear force. Consider a support section at a distance x from point A. Consider a section. So distance is x. Here only one force is there. I am writing that shear force at only one force is there, that is RA. This is sign convention. Sign convention is based on left of section and right of section. Shear force, upward force and downward force is positive. Upward force in left of section is positive, and right of section downward force is positive. In downward force and upward force is negative, that is shear force. In bending moment, anti-clockwise direction and anti-clockwise direction positive, clockwise and anti-clockwise direction is negative in right of section. Coming to bending moment. Bending moment, this is also same. Consider a section. Moment is nothing but force and perpendicular distance. Here the only one force is there. If you consider that section, here only one force is there, RA. Distance is x. Force, you got the value support reactions W by 2, multiply with x. You are taking that values x equal to 0. Here the bending moment at ends is 0. I am drawing the diagram also. This is at 0 point, is also 0 point. WL over 4. At center point, bending moment is maximum. Shear force is at end points is maximum. Bending moment, we got the values WL over 4. So this is for point load or nothing but concentrated load. Coming to UDL or uniformly distributed load, the values is calculated like that only, but the values will change. Why? Because load is UDL, uniformly distributed. Shear force is WL by 2. The bending moment is WL square over 8. Let us take an example that design of simply supported beam with grade of concrete is M20, Fe 415 steel. Live load is 15 kN per meter. We are taking that IS 456 code book, manual calculation, and page number 87. We are calculating, taking formulas, moment of resistance and limiting moment. Here the calculation of depth of beam. First step is calculation of depth of beam. Formula is L over 12 to L over 15. The length of beam is 6 meters. Assuming that length of beam 6 meters. Here I am taking that converted into mm. So 6000, 1 meter is equal to 1000 mm. 6000 divided by 12 to 6000 to 15. So the minimum value is 400. The maximum value is 500. So I am taking that assumed value in between the values. So 450 I am taking that. This is the effective depth. And cover we are taking that 20 to 30 mm. I am considering the 20. So overall depth is 470. Next step is calculation of breadth. D by 2 to D by 3. 450 to 453. So taking that, B is equal to 200. Next step is calculation of loads. Dead load, live load. So multiply addition of two loads, that is nothing but total load. Dead load, this is nothing but density of concrete with area of cross section. Dead load is the weight of value is 25 kN per meter cube. Here the values are in mm, so you should convert it into meter. Why? Because the value it is in units are in meters. So after that, the value is 2.35. Total load is live load, addition of dead load. So we got the value 17.35. And next step is calculation of shear force and bending moment. So we already discussed before that. So value is WL/2 to the 52.05. This is the shear force. This is the bending moment. And after that, this is the in page number 56 in IS code book 87. Moment mu limit is equal to 0.36 xu max by d, 1 minus 0.4 to xu max by d, bd square fck. B is breadth, d is depth, fck is characteristic compressive strength. In given data, they are given that M20 grade of concrete. M is mixed proportion, that is cement, sand and coarse aggregate. So after substituting that, we got the value in Newton mm. This is singly reinforced beam. There are two types of beams, are doubly reinforced and single reinforced. If your value is mu greater than mu limit, that is doubly reinforced beam. This is your it is under only, so it is taken as singly reinforced beam. So again in page number 87 IS code book, and formula is there. Mu is equal to 0.87 FASTD 1 minus FAST or BD FCK. So 0.87, you got the value. After calculation is that this is the AX square BX plus C format. So I am using calci, and after that calculating the value area of steel, and I assume that 500 mm square. And also I am calculating minimum area of steel and maximum area of steel. Maximum area of steel is, we are taking that same IS 456 code book, 4% of gross area. Gross area is nothing but total area. Here to total area, the section is rectangle. The area is length into breadth. So the maximum value is 3760. So I assume that value, minimum value also are considering that 391 to 3000. That I am considering the value AST is 900 over pi by 4 d square. The formula is the bars are in circular shape, so the area is pi by 4 d square. I am considering the value 16. Why? Because inside 6, 8, 12, 16, 20, 25 and 28 bars are available. So for residential buildings, the beam minimum value you are taking that 16 to 12, 16, 20, 25 and 25 based on that load. So I am taking that 16 is suitable or checking that. So we got the value 4 bars after calculating. So and stirrups, we are assuming that the bar dia is 8 mm up to 12 mm is the maximum. The minimum value is 6. So I am considering the 8 mm. So this is the overall, this is the clear cover, and this is the overall width and overall depth, and this is the design of beam cross section. This is the shape is the cross section. Thank you.